Cool, cool. Hope you're having a great day. We are looking at finding missing links, and we're going to use our trigonometry to be able to do this. So now we're using those ideas of our ratios to putting them with some a little bit of application with them so that we're actually using them now. Please don't forget, just a quick reminder, the sine of an angle, remember this is an angle, is equal to the opposite side over the hypotenuse side. You want to remember all these. Cosine of an angle is equal to adjacent side over the hypotenuse. And then the tangent of an angle is equal to the opposite over the adjacent side. And so we need these. Really what we've done is we're going to be given these triangles, and we're going to be given two bits of information. In this case, we're going to be given an angle measurement and a side length, and we're going to substitute them into our rules here and then just solve. That's literally what we're going to do, okay, is substitute and solve. So I'm going to look at this triangle right here. The first thing I'm going to do is say, okay, where's my angle? My angle's right here. I have my hypotenuse side, which, again, I know that because that's the longest side. And then I have the side that's away from my angle, so this has to be the opposite. I know this is the angle I'm talking about because I know nothing about this angle. So that's the opposite. And then the adjacent I don't know anything about. So once I've done that, I'm going to say, okay, what trig function deals with opposite and hypotenuse? That's sine. So I've got sine here, and I need to substitute for this angle. And then I need to substitute the opposite and the hypotenuse side. So I'm going to go sine of my angle, which is 16. So 16 goes there. The angle always goes here, people. And then that's equal to the opposite side, which is x, all over the hypotenuse, which is 18. Okay? So identify the trig function. Then I substitute, and now I solve. So solving, let me make a suggestion to you. I would type this sine of 16 into your calculator. Okay? So sine of 16. Which that will, and then I would go to like 4 decimal places, so 0.2756, and that's equal to x over 18. I'm trying to get x by itself. So to do this, because it's x divided by 18, I can times by 18. That'll cancel that out. I just have to times this by 18, so I just hit times 18, and that gives me approximately 4. Again, 9, we'll go 9.6 for that. And that would be my solution. That's the distance that I'm going to have for this. So if 18 was like 18 feet, this would be 4.96 feet. Okay? That's the process with all of these. Identify the trig function, substitute, and then solve it. So let's do that with this one here. So here's my angle. This side is the opposite. Again, I always draw that angle or that arrow to help me. And then this side, this is the hypotenuse over here, so this has to be the adjacent because this is the hypotenuse, which has nothing, so I'm not going to use that. So I need the trig function that uses opposite and adjacent. I go over to my rules. Opposite and adjacent is tangent. So I'm going to go tangent. And then I'm going to substitute tangent of my angle, 31. Again, the angle always goes here. The opposite side, again, opposite over adjacent, it doesn't matter which one goes where. So this is going to be x over 10. And then I'm going to solve. The first thing I'm going to do is type in my calculator tan of 31, the left-hand side there. And that is going to give me 0.6009. We want it, I'd go out to 4 for this just to kind of keep things, or just cut and paste and use the whole value. Then I'm going to get x by itself, so I'm going to times by 10, times this by 10, and that'll give me my final value. And so I get x equals 6.009 is what I'd end up with that. So that would be the distance from this point to this point. It would be 6.009. We're finding those missing links and those missing distances here. Let's do a few more here. So I've got this one again, identify my angle. There it is. I've got the hypotenuse, and that's the opposite, so this one has to be the adjacent. So again, I need to know what trig function uses adjacent hypotenuse. That's cosine. Then I put my angle. I'm substituting here. I do adjacent, which is x over 12. Type in cosine of 54. Go to 4 decimal places, 0.5478. And then that equals x over 12. Times by 12. And times this again by 12 here. And that'll be 7.05. And that's what x is equal to. Bada bing, bada boom. I put these last two on just to make sure, just a little variation here. Make sure we're not getting too far ahead of ourselves. So again, same process, identify your trig function. There's my angle, there's my hypotenuse, and then my opposite would be here, so this has to be the adjacent. So again, I'm using cosine, so I'd go cosine 63, and then I go my adjacent, there's 23 over x. The reason why I did this one is because these last two have the x's in the denominator. It's important that you put which, if it's the adjacent over the hypotenuse, you put the adjacent over the hypotenuse. Don't try to just assume the x is always in the numerator. So once we do this, let's solve this. This is cosine 63 again. Type that in. I get 0.45. 4540 is what I have here. And then that equals 23 over x. Now this is where this changes a little bit. I would still times by x, guys. Get rid of your fraction. Okay, and what that gives me is 0.454x all equals to 23. And then we have just an extra step here. I'm going to divide by 0.454 to get rid of that, so I have the x over here, 0.454. So I'm going to have x equal to 23 divided by 0.545, and I get somewhere around 50.66 is what I get. And this is, again, that's going to be that distance from this point to this point. So a little bit different. Ooh, that was bad. A little bit different on the solving part because the x is now in the denominator, but just times by x and then divide by your number over. Ends up being really nice there. Let's do one more of those. So there's my angle, here's my opposite, and here's my adjacent. So opposite and adjacent. Oh my gosh, I cannot do a G here. Or D here. So I know opposite and adjacent is tangent. So tangent, angle, which is 38, equals opposite, which is 20 over x. So I have the x in the denominator, so this is going to be the same type of deal here. But type in tan 38 first. That gives me 0.7813. And times by x, boom, boom, those cancel out, times by x here. So I've got 0.7813x equals 20. And then divide by your 0.7813. And so I get x equals to whatever that is, 20 divided by 0.78. And so I get 25.60 if you round. And there you go. So this helps us find those side lengths, which is awesome. And there you go. This has been your Math Moment with Money. Adios.